Thank you. Hi,
Welcome back,
guys.
everybody, to the 7A channel. We're back. I'm back. My host is back.
Hmm.
And basically, today, I've been told to cover science once again about displacement, speed, velocity, and distance. And how long has it been? Well, 1 year. It's been one whole year since I did a video with y'all.
I
Oh, you can't get
Yeah,
rid
it's
of me,
been
and you
one
never
year.
will. So, joke's on you. Okay, so let's cover basic terminology, okay? What we're going to cover today is distance, displacement. I just wrote displac for short, you know. You guys already know how to spell displacement. I don't. Velocity, speed, and these are the four key terms we're going to be covering. Please do not mind my spelling. It's garbage. It's very, very, very extremely bad. But who
Okay, I get
cares?
the point.
Let me show you guys what these terms mean using a simple example, okay? So let's say, okay, I should not, okay, there we go. Let's say I have this rectangle, okay? This rectangle is a, let's say this rectangle is a garden, okay? Let's say this rectangle is a garden, okay? In that garden, we have a brown path. We have, well, roads, okay? Let's say there are paths in the garden. Here, there's one here, there's one here, okay? So like it's a four-way path, okay? Oh my God. Okay, let's say we have a path here. Let's say that your friend has invited you to come over to his house for a party, okay? So the red is you and the purple is your friend, okay? Red is you, the purple is friend, okay? Basically, using this example, I'll cover what each term means, okay? Let's start with distance, okay? Let's say I wanted to go to the birthday party, okay? And I took the route. First, I went right. So I keep going right. And then I went up to get to my friend's house, okay? From my house. So basically, from that example, you understand that distance is basically the total or the length of your path traveled, okay? So let's say that to the right, you traveled 5 centimeters, okay? Let's just say 5 centimeters, okay? If John can buy 100 watermelons in the math problem, then I can make my path 5 centimeters. Then let's say this is 2 centimeters. I know this is not realistic, but who cares? 2 centimeters. So your distance is basically the length of the path traveled, okay? So it'll be 5 plus 2. So the total distance you traveled will be
Will be
your
7.
5 plus 2, okay? 5 plus 2, which will be 7 centimeters, okay? So you can just get it from what path you're traveling on and the distance of that path. Now let's talk about displacement. Let's say you're late to the friend's birthday party. And like me, you would want to find the shortest way possible to the birthday party, okay? So let me just clear this really
Uh-huh.
quickly. Okay, let me just clear this. So you see how distance is the total distance or of the path, length of the path traveled, right? Displacement is
Displacement is
pretty
something
much
different.
the shortest path to your final destination. Okay? So here I'll use a bit of terminology. So your starting destination or your house will call the initial destination. And your friend's house will call it the final destination. Okay, let's say that you're running out of time. Okay? So you want to find the quickest way possible to your friend's house. And we all know that the quickest way possible to anything will just be a straight line, okay? So I can just simply draw, I don't have a ruler on me, but you should use a ruler when you're doing this. You can just draw a straight line from your house to your friend's house. I know this is not exact, but still, according to mathematics, and I won't be proving this mathematics why it's the shortest distance, because God knows, some dude just said, okay, so just trust him. I'm joking. But still, displacement is just the shortest distance to your final destination from your destination, okay? And basically, if all the keen watchers all the eagle-eyed viewers probably wondering, oh, now that's a triangle. And you're right, it is a right angle triangle. And you guys covered this in math, I know, because we covered it too. Okay, this is when we'll use Pythagorean theorem. Okay, you have not escaped him yet. You thought he was just in math, but now he's in science too. Haha. Okay, so let's say you go to the right 5 centimeters. Okay, let's just use better. Yes, let's just use a Pythagorean triple to make it easy. Okay, let's say it's 4 centimeters to the right and 3 centimeters up. Okay, 3 centimeters up. To calculate displacement in such a way, in such an example, what you do, you can just use Pythagorean theorem. So a squared plus b squared equals c squared. Okay, so basically in this case, your hypotenuse or your displacement will be the c. Okay, so 3 squared you can just do, which is 9. 4 squared you can do is 16. 16 plus 9 equals 25. And if we square root 25, that just gives us 5. So we know the displacement is 5 centimeters long. And can you see how your displacement is always smaller than your distance? Because your total distance, 7, you see how it's bigger than your displacement? Because displacement is always the shortest route possible. Okay, clear? Now, another concept I want to cover in displacement is that sometimes displacement can be 0, okay? Let's say that you go to your friend's house and then you go to this path and you come back to your house because, of course, you won't be staying at your friend forever. So once you come back, your initial destination will be where you started from or your house. And your final destination is where you are currently after the journey is finished, which is again your house. If you reach from your house to your house, we can see that the distance is just 0, okay? The displacement is just 0, okay? Because that's the shortest route possible to get from your house to your house, because the final destination is your house. Okay, I hope that makes sense, because the shortest distance to your house will be your house because you're already there. Okay, I hope that makes sense. It might be confusing, but you'll get it. Okay, another important thing I want to cover is about vectors. Okay, vector, and scalar. Okay, scalar. Okay, now you might be wondering, what are these hefty terms? Okay, so I'm back. Sorry, my internet was not that good, so I sort of disconnected. Okay, but I was talking about vector and scalar. Okay, so basically, scalar and vector, in simple words, vector is magnitude and direction. Magnitude and direction. Direction. Scalar is just magnitude, or just like the size or the length of your distance. Okay? So you can see how distance, generally you can go up, down, left, right. You see how you can go in any direction. So it doesn't have a specific direction, okay? So we can say distance is scalar, okay? And so it just has magnitude. It just has a size, or it just has a length, like 7 centimeters. It doesn't specifically have one set direction, okay? Because you saw here we're going to the right, then we're going up, then we're going left, then we're going down. So it doesn't have a specific direction, okay? Then, but displacement, we can all tell that it's a specific direction because it's a straight line. In this example, it's going east and it's going to the north. So it'll be northeast, okay? So remember this, when you're tackling displacement, whenever you're calculating the displacement, always make sure to put the direction, because displacement always has direction, okay? It's a vector quantity. It has direction. Distance doesn't have direction, okay? Now we'll tackle velocity and speed, okay? These two terms are pretty similar to one another, and it might be sometimes difficult to distinguish between both of them. So basically, okay, let me just explain it to you in simple terms. Okay, let's say you walk to your friend's house, okay? You have a distance of 7 centimeters and you walk to your friend's house, okay? Let's say this walk takes you about 10 seconds, okay? 10 seconds. okay? So basically, your speed would just be how fast you're walking or how fast you're reaching your destination, okay? To calculate speed, what you do, you get your distance, which is 7 centimeters in our case, and then you divide it by your time, okay? So speed is basically a rate, okay? It's the rate of your distance to your time, to the time it takes you, okay? So how long it takes you to reach your destination or to reach your distance, okay? And so we all know that rates have a quantity of time, okay? Rates always have a quantity of time and are always a fraction because you divide by time. So in this case, to calculate speed, what you can do, you can get the distance over time, okay? So in simple words, it's just distance over time, okay? Velocity now is like, it's sort of like speed, but instead of calculating from the distance, we calculate the displacement, okay? Velocity is with the displacement. So the shortest path possible and the time it takes you, okay? So let's say you're Naya Lakhani and you're very late for a party. Let's say then you know you'll be late, so you take a bicycle to get you there faster, okay? Let's say that using this displacement path that we've made, which is a line, a straight line, let's say, and this was 5 centimeters, right? So you just put the value of your displacement, which is 5 centimeters, over the time it takes you. So let's say I took a bicycle and it took me only 5 seconds to reach to my destination. So we can say that velocity is just, you see how speed was distance over time? Like how much time does it take you to get to a certain distance? Velocity is just like that, but instead of having distance, it just has your displacement. So how long it takes you to cover your displacement, okay? To cover the shortest path possible, okay? So this is just displacement over time, okay? Now I'll cover two more concepts really quickly, okay? One concept that I want to cover is uniform motion, okay? Uniform motion, okay? So let me draw a car. Excuse my drawing. Let me draw a car, okay? This car is traveling at a speed, sorry. Let's say this car is traveling in the first second, okay? First second, it travels 1 meter, okay? This car travels in 1 second, it travels 1 meter. Let's say in the next second, it's second number 2, second, it travels 2 meters. Let's say in the third second, it travels 3 meters, okay? On and on and on and on, okay? Etc., etc., etc. This is what we call uniform motion. Uniform motion, okay? So basically, uniform motion in the simplest terms is just you're traveling equal distances in equal intervals of time. Now, one thing to remember about uniform motion, it's always in a straight line, okay? It's always in a straight line, okay? Simple. So basically, you can see how these distances are equal. So 1 centimeter, 1 meter, 1 meter, because the difference between 2 and 3 is 1. The distance between 1 and 2 is 1. And this goes on and on and on. And what can you see here? The seconds also change by 1. So you know this is uniform because both the distance and the time, they travel in intervals of 1, okay? I hope that makes sense. Now, basically, let's draw another car, okay? Let's draw another car. Let's say this car in the first second, it goes 5 meters, okay? Let's say in the second second, I love saying second, it goes 7 meters. Let's say in the third second, it goes 4 meters, okay? You see how this is unpredictable, okay? So 5 to 7, that's a difference of 2. 7 to 4, that's a difference of 3. You see how this is unpredictable? And you see, what is the difference between 1 and 2? 1 and 1. You can see how the seconds don't match the time. So this is what you
Yeah.
call non-uniform. Non-uniform. Non-uniform motion, okay? So basically, if you want the textbook definition, it's just you're traveling unequal distances in equal intervals of time. Remember, in uniform and non-uniform, the time does not change. The time is always equal, okay? So if you're going 1 second, 2 second, 3 second, it'll always have to be continuing that pattern to 4, 5, 6, 7. It can't be 2 second, 6 second, 9 second, 2 second, 3 second. It can't do that. Time must always be equal because that's just confusing, okay? But the distance can vary. And that's what we call non-uniform. Okay, now let me just, okay, another concept that I want to tell you guys is how to measure displacement and, what do you call it? Displacement and thingy, because I've already taught you guys how to measure speed and velocity, distance over time, displacement over time. Now I'll tell you guys how to measure displacement and distance, okay? So distance, let's say in our example, going to your friend's house, you can use maybe something like a tape measure, okay, to calculate your distance. So let's say it's 5 centimeters to the right, 3 centimeters up. You add these two together and it'll give you your total distance, okay? But in a realistic example, you won't have something like that, okay? You won't just use a tape measure to measure long distances. Instead, what you can do, there's devices built for that, okay? If you check your car, there'll be a odometer, I think it's called. So basically it checks the distance, it checks the distance that your car is traveling. So let's say it takes, let's say you go from Mombasa to Nyali. Let's say how many kilometers would that be? That's approx, let's say, for the sake of this example, it's 10 kilometers. So in your odometer, in your car, there'll be like a wheel, not a wheel, well, there'll be like a display. It'll say something kilometers, okay? Your car can start off with 2 kilometers, etc., etc. Okay, so let's say your car starts off with 2 kilometers. Let's say the car has already driven 2 kilometers. Then, and 2 kilometers is from your starting point. And let's say you want to go all the way to South Africa in your car. Okay, this is your final destination, South Africa. Okay, and then let's say it goes up by 100 kilometers. Okay. Now to calculate the distance that you traveled, you minus the larger distance by the smaller distance. 100 minus 2 equals 98 kilometers. So the distance you traveled is 98 kilometers, okay? Cars also have a special thing for speed and velocity. So you can also check that. There'll be like, there's one for RPM, rotations per minute, and next to that, you'll be able to check the speed. And this speed changes, and the car basically calculates the speed every millisecond, every second, and it tells you what the speed is. So every time you go faster and press the accelerator, you'll see the speed rising. And when you don't, when you press the brake, you'll see it lowering. Okay, now I'll talk about displacement. Another good way to measure displacement is using a map, okay? So let's say you want to go from country A to country B, okay? Displacement, we all know, is a straight line. So what you draw, you just draw a simple straight line from country A to country B, okay? Then using your ruler, you measure this line, okay? And maps generally give you a key. So for example, 1 centimeter equals 1 kilometer in real life, okay? So once you measure, let's say this is 3 centimeters. So you know now that your displacement, the shortest path, will be 3 kilometers, okay? You can use a map to measure it too. And always remember, displacement is mostly a straight line, okay? I think that covers it all. If you need me to cover anything else.
Not really.
You need me to cover?
Yeah, that's it for the video.
Okay.
Thank you guys for
Are you
watching.
sure this is all?
Yeah.
Okay. And also, I've seen that you guys are given graphs. Okay. So just like I told you in the methods, so let's say you're given a table, and let's say the clock reading, it shows you a diagram of a person walking. Okay. So let's say in 2 seconds, he traveled 4 centimeters. In 4 seconds, he traveled 8 centimeters. In 6 seconds, he travels 12 centimeters. Okay. It's the same thing that I did and taught you guys about the basic concepts. Now you can just apply them in these kind of real life examples, okay? So I've taught you
Okay.
guys the formulas, okay? Now,
Yeah.
now with those formulas, if let's say it says that my car traveled a distance of 5 centimeters, okay? And my car took 5 seconds to travel those 5 centimeters. What is the speed? Okay, so you can just put distance over the time it takes you and then find your speed. Speed is generally measured in meters per second, kilometers per hour. These are generally, or miles per hour if you're American. These are generally our SI units, standard units that everybody discussed on having. And as for velocity, it's also measured in meters per second and stuff like that. So for example, if it asks you about velocity, then you know it's displacement over time, which makes life simple. And since you know how to, since you know basic algebra, if you have the formula velocity equals displacement over time, you know how to calculate time. Okay, and you know how to calculate displacement if you're given velocity and time, or let's say velocity and displacement, right? That's just basic algebra, okay? Now, if you don't know algebra, we also have videos on that, so you can watch our algebra videos. I'll link them. Guys, please watch. We need money. We need viewership. Please, guys, we need views. Anyways, guys, hit that subscribe button. Destroy. I mean, destroy that like button. Put please bell notification. I'm begging. Or I want if you guys don't subscribe, I won't release another video. I should not say that, then you all won't subscribe. Okay, if I don't subscribe, I'll take one of your friends hostage. Bye, guys. Okay,
Bye,
YouTube,
guys.
don't demonetize me. Okay, bye, everyone. Hope you can understand now the basic concepts. Have a good day.
Bye.
Have a
Have a good
damn good
day.
life.